Hello, everyone. This is keeping your IoT fleet afloat with Sync. Thanks for showing up here, or thanks for watching the video. Just real quick, I tried to put some kind of buzzwords to give you a sense of what I'm going to be talking about. So IoT, or Internet of Things, M2M, or machine-to-machine communications, event-based systems, and a little bit of Nerves. And I'm guessing there's a large overlap. Can I see who was at ElixirConf this morning? All right, pretty good show of hands. Cool. Yeah, that was a ton of fun. And so just some quick background about this talk. This is really a follow-up to my talk last year, which, if you're watching the video, I'd say probably watch that first because it's a little more general and it'll give you more of a sense of kind of the problem space. This is diving down a little bit more into the weeds, so thanks for bearing with me on this. I think for some of you, this is going to be very much hitting a pain point from what I've heard and from other folks. Sorry, this isn't live view. This is going to be a very niche talk, but thanks for sticking with me on this. And Sync is just this kind of library or abstraction about how we communicate between some of our devices. This is what we use instead of MQTT to make sure that we can replicate what we want to do between the ground and the cloud. And the target audience for this talk is people who are working with Nerves or event-based systems or just kind of distributed systems in general, or are curious about some of the challenges there. And some of the takeaways I hope you get are, what are some of the challenges in these machine-to-machine communications problems that inspired this Sync thing? What are some of the approaches that Sync takes to address these challenges? What is the state of the Sync project? And lastly, this is ElixirConf. How does Elixir fit into all this? So hello, my name is Mike Waud. I work for a company called SparkMeter, and SparkMeter offers grid management solutions that enable utilities in emerging markets to run financially sustainable, efficient, and reliable systems. So I totally yanked this slide from my talk last year. So this 120,000 meters sold is definitely old. I really don't know what the number is now. But so kind of what we do is we design and we sell smart electrical meters. So these will do things like measure electricity usage, measure general kind of health of your grid. You can remotely turn these on and off. And we sell grid management software, which communicates with these meters and does some really interesting things. It gives you a lot of health information about your electrical grid. And it's fascinating. A lot of this is in Africa or like Southeast Asia. And we talk to people in the US, and the features that we can give folks into the developing world is stuff that we're still struggling with in the US. So it's really interesting to see how far ahead software is in some places and how far behind it is in some places. And so we're working to kind of speed up some of this grid management software. And another thing we enable is prepayment for your power. So in the West, we typically think of, I used a bunch of electricity, now I'm going to pay for it. In other parts of the world, it's more along the lines of thinking of, okay, I have $100 paid of electricity, and that also really helps kind of these electricity providers to know that, hey, I have this budget to work with within my electrical grid. We also do some digital solutions, which I won't talk about here. And I'll quick tout that Fast Company back in 2021 said we're one of the most innovative companies in energy, which was pretty cool. So the project I work on is this next generation base station, which you see here in the middle in blue. And kind of the way this works is we have these smart electrical meters over here on our left, which are, they're doing their thing, they're measuring how much electricity is consumed, they're turning off and on, and they're communicating with each other over RF in like a mesh network to this central base station here, or collector, some people call it. And a lot of the brains and a lot of what I work on happens in this middle thing, this collector, where it's taking the communication from these meters, it's doing some sort of processing, typically like billing and those kind of behaviors, and it's communicating back to the meters. At the same time, it's talking typically over a cellular connection to the cloud, where we have our servers and we have like a UI and an API, all the kinds of things you would think. So we run Elixir and Nerves on the base station. We also run Rust for just some kind of RF sensitive, performance sensitive things, and we also run Elixir in the cloud. And Nerves we've been super happy with, very great to run, and being able to use Elixir on the device and then in the cloud just makes it so much easier to develop features and to launch. I can't imagine doing it without it. And in the context of this talk, if you hear me talk about the ground, I'm talking typically about the base station or kind of what happens on site. And when you hear me talk about the cloud, that's the cloud. And thinking about this a little more, we have this base station, which it's doing these things about it's managing billing, meters turning on and off, going into like protect mode, and it has its own internal state. We happen to use SQLite for a lot of things, but you can imagine whatever this is. So it's keeping track of things, and it's always like, hey, cloud, like this thing happened. Let me tell you about it. And then the cloud is like, wait a minute, I have these things to tell you about. And so they're talking back and forth, and particularly, if the internet goes out, you're kind of trying to figure out like what to do. And it's a really interesting challenge. So the way Sync came about, and here's our little kind of blue logo, which I love having a logo for a project. It certainly makes it more fun. Sync came about of like, well, how do we let the base station focus on being a base station and keep that application logic there? How do we keep the cloud stuff there? And how do we push this data communication of in-between and synchronization into like its own project so we can get a lot of the practical benefits of clear abstractions? And I think testing is a really important one here, where you could think about testing these systems individually, but by having this abstraction in the middle, we can start running some of our tests kind of against that abstraction itself. So as far as those problems, I'm going to separate this into kind of 3 bullet points for this talk: device interop, reliable data synchronization, and event-based system features. So as far as the device interoperability, let's talk about what could go wrong. So we could have incompatible software versions between client and server. So this might happen in your normal development workflow where you're just releasing a new feature, and you got to make sure that a feature which spans the cloud and the ground talks to each other. So which one do I roll out first, that kind of thing. You kind of have a similar case if you're thinking about like a web UI. But another really practical situation this comes up is, we would manufacture a whole run of these devices, and they sit in a box somewhere until someone opens that box and plugs it in. And that could be days, that could be weeks, that could be, I don't know, like a year later. So the firmware that we put on this device when it went into that box is now trying to talk to our servers. So that's certainly something that can maybe not go wrong, but it's a problem that we have to deal with. Another interesting thing is this idea of inconsistent state between ground and the cloud. So where this might happen is, you're going to have a QA and a staging and a prod environment, and you have a real device, and you might have a developer who's testing features, or there's like a demo unit, and people are moving these back and forth in between these environments. And I think a lot of us have seen in our careers practically, you have something that shifts between these, and all of a sudden you get weird data either in your production environment or staging, or things just happen that you don't expect. Another similar kind of situation is if your device has multiple ways to boot, maybe eMMC and SD, you might boot to SD, and all of a sudden you get this kind of same situation of your device, I don't know, it's like it had amnesia and starts acting like a new device. Another scenario is if someone wipes the device or does kind of like a factory reset where they just blow away the database. Again, you have your patient with amnesia, and they're saying like, who am I? You look familiar, but I don't remember anything you've ever told me. And lastly, maybe this is a device we don't like. Maybe it's a software reason, there's some bug, and it just keeps spamming us with errors. Maybe there's a hardware issue. Maybe we're just working to fix it, and we just say like, don't connect to our network, you're giving us some issues. And so this is kind of the nitty-gritty, but in the Sync way of thinking about this thing, I think this is a fairly standard approach. When a device first connects, it sends this connection request message. And so it just says, I want to use this version of the protocol. I am running this application version. So the firmware that it's running itself, it will say, here's who I am. And there's this idea of an instance ID. Some people will call it a consistency token. I've seen it referenced to. And that is just something that references the state of the device. So maybe it ties to the database or something. And if that were to change, this would also go away. And so when the device connects, it sends all that stuff up to the cloud. And then the server basically says, all that stuff checks out, cool. Or if it's a new device connecting it the first time, it's like, here's your instance ID, whether that's a UUID, timestamp, whatever. That's just some way of uniquely tracking the state of that device so we don't get this staging production issue. And then, maybe there's an error. Maybe we don't support that version of the protocol yet. Maybe that application version, this just came out of a box and it needs to update. So don't connect to our servers until you've updated. Or lastly, this idea of quarantined, which we totally stole from Nerves Hub, which is basically, we don't like you, take 5 minutes, 30 minutes, whatever, connect again, maybe we've resolved the issue. There's just some sort of abnormal situation going on here. So as far as our actual problems, how are we doing on addressing these? Well, by requiring this application version, that helps us handle this incompatible software version challenge. For the inconsistent state, this instance ID is kind of the idea of how to address that. And the device we don't like, boom, you get quarantined. And moving on to a little bit more of a challenging one is this reliable data synchronization. And kind of what could go wrong there, man? A lot of stuff. The simple one is just the connection is down. It's a cellular connection, stuff is just going up and down, maybe power is going out, who knows? And so typically for that, you just want to queue messages up and have some sort of way of tracking that. This unreliable connection of we might send a message and it looks like it went out, but we don't know if the peer on the other end actually got the message. How do we know that for sure? And how do we avoid problems coming from that? Another interesting one is delivery status, where someone might say, hey, I want to do this thing. I want you to turn this meter off. I want you to make this payment. And let's say the device is not connected. We queue that up, but then someone might say, okay, was that payment made? What's kind of the status of this thing that went out? So that's something that we get asked frequently. Another interesting one is if a message was rejected. So everything's going along fine, but maybe there was a new deploy and this bug happened and all of a sudden things aren't going smoothly. Well, do we keep going? Or do we stop synchronizing? Do we skip this? If we skip this, is that going to cause a problem? These are kind of real world problems. And they can really snowball kind of in the cloud where all the devices are communicating and you have the potential for one device to stop replication for other devices. And lastly, here's a really interesting one, which is a message might be out of date and we're sending stale data. So you can imagine an access control lock or something where someone says, okay, open the lock. And then they change their mind and say, okay, close the lock. Wait, no, open it again. Well, now when the system comes back online, what do? Do we have this lock that's opening and closing, opening and closing? It's a very interesting real case. And for our case, this might be someone's power goes out and comes back on and whatever, looks like a ghost. And yeah, these are all really tough. So let's skip ahead a little bit and let's talk about event-based systems and see if that can help us to think about this data synchronization a different way. And before we talk about event-based systems, well, let's talk about what is not an event-based system. And one of the ways I think about this is your kind of classic request response, where things basically just happen, and they happen synchronously, and they happen blocking. So a good example of this is like a UI on a website, where someone clicks a button, I don't know, submit this form, or add this user, and that makes a request to a server, and then the server's like, cool, 201, user created, or 422, or whatever your error code is. And it's interesting to think about this in terms of the user clicks the button, and the server determines if the user clicked the button or not, which is sort of a weird way to think about it. In the real world, they click that button, but the server is the one who determines that thing actually happened. So if you kind of contrast this with an event-based system, when someone clicks that button, what you would do is you would write to some event log or event stream of this button was clicked. And then that would kind of asynchronously propagate to a consumer. So now your real world thing of this event button being clicked, that happens, and the consumer now kind of has to deal with, well, that happened, I don't like it, but I have to deal with it in some way. So, if you've worked with asynchronous stuff, this kind of isn't a surprise, but it really can be a useful way to think about situations like this. And I find this really funny because we're used to, in the actor model, thinking about this similarly, but in kind of a different way, where we have processes that communicate with each other, but they're sending messages to a process mailbox, which lives in another process. And so the event-based system is really similar to this, but it's almost like you take this mailbox and it's like an outgoing thing for your producer. So it's sort of the same, but it's almost an inversion of it. And if we look at our practical example of someone wanting to turn off a meter, in this request-response world, they would make the request. This would go out over cellular to the base station, which would then go out over RF to the meter, and the meter would say, like, yep, I turned off. And that would make its way all the way back to the initial requester. And if I could do this, man, it would make my life just so much easier to live in this world, but that's not the world we live in. So instead, what we basically have is this real asynchronous non-blocking thing where someone says, turn off the meter, and we're like, on it, I'm turning it off. And that propagates its way as it can to the meter, which will then make its own separate new event, which propagates its way back up to the cloud, and then we link back to the initial request such that when someone says, like, hey, I asked you to turn this meter off, did you do it, yes or no? We kind of know, like, well, you asked us to do it, but we haven't gotten the response yet, or yeah, we got the request and the response, and it's now we can confirm it's off. So by using an event-based system, that helps us to solve a lot of these data synchronization kind of questions, where in some ways it's just like a queue of messages that you're sending from one place to another. But another way, it really is a log of these things that happened, which can be useful in other ways. So this event log, like I said, turns into the queue. For these questions of reliability, well, we just track events that we've sent and what's been acknowledged by the consumer. And using that, we can figure out where we are as far as the synchronization of the replication. And the question of the message was rejected. There are kind of a couple different ways to handle this. Probably the easiest way is to segment your events by different things. So you might have your kind of control messages of like, hey, I want you to reboot, or I want you to update, and that would be separate from your like sensor readings or your meter readings, which would be separate from maybe you're recording CPU usage. So someone's working on the CPU usage part and there's a bug there. Well, that doesn't stop everything else. Another way to do this is to really completely isolate all your stuff. So in this case, let's say we have 1,000 meters associated with the base station, and one of those is giving us a problem. We just wouldn't send that until we get a fix. We would send the 999 other ones. And that can be useful, but if you're doing aggregations or you're doing any other thing where you depend on everything coming in sequential order, you can get into trouble. And as far as our message being out of date problem, some event-based systems will talk about topic compaction. I think that's what Kafka calls it, or a fast forward. This is the idea of we know within the event stream that we have newer events, so let's just send the very latest. And that can work really well unless you have maybe a reference to some other event which wasn't sent yet. So you can really mess with message order to good or bad effects. And so for our last one, let's talk about event-based system features a little bit here. What could go wrong? Well, a lot of stuff. I kept this slide short. There's definitely more stuff here. But kind of the classic one is this. We have a distributed system, and we have two different things talking to each other. And it's very possible that the consumer is unable to understand a message that the producer sent. So fortunately, with our application requirement from earlier of saying, like, making sure our firmware is up to date, we can avoid this. But this is still kind of a tricky one. What if we receive the same event twice? Certainly a cause for concern. How do we know if we're missing events? So for us, because we're dealing with billing, we want to make sure that all the payments that have been accepted in the cloud make it to the base station. And another really interesting one, how do we prevent a large number of events from filling up the disk? This slide's really boring. I'll try and cruise through it. But this is kind of what a sync event looks like. There's this idea of a key, which is just sort of your unique identifier, whether it's a UUID or a serial number. It's just some way to make it unique. This event type ID, this tells you what it is. It's almost like a table name, whether that's a meter, a user, a meter reading. A schema version, this is maybe a little more interesting. This is how we determine if we've changed the schema. So maybe we have like a user record, and we've added a phone number or a last name, or we've changed something from like a string to an integer. when we do that, we bump this. This would be, if you use like Avro or Thrift or something like that, there's a lot of really interesting stuff with backwards and forwards compatibility. This is just an additional way we kind of, on top of that, track how we've changed and evolved our schemas. Offset is this auto-incrementing ID of, it's kind of like an optimistic lock, where if we have a new version of a user or a new meter reading comes in, it just is the next one. Timestamp, self-explanatory, and then the payload is anything that's not that. So, there's a ton of different ways you could really slice and dice this. This is sort of what we came up with. And so when I talk about sync, it's just like this specific event structure that we have, which has worked well for us. And then there's also this binary protocol of like, okay, I can speak this event and go from one place to another. And so how does this address our what could go wrong questions? Well, this schema version field helps us in schema evolution. And I'll just make a quick note about that backwards compatibility stuff. You might have a backwards compatible schema, but if there's something that you're trying to send that is dropped in this backwards compatibility, you still lose that and you have to deal with resending that. And for the same event twice, we have this offset so we can say, hey, we've seen this offset before, or this offset's older, we just ignore it. And for missing events, since we have this sequential offset, the timestamps aren't good enough, we can just say offset 1, 2, 3, 4, 5, we know where this is in the sequence. And the large number of events on a disk, this is where I think event-based systems really can shine, where it really makes you think about, as your system grows with volume of data or in time, it really becomes the volume of events. And it makes you think about, how is my system going to deal with these events as they go along? And you can come up with retention policies that dictate deleting or archiving old data. You can say, everything 10 events ago I want to archive, or everything a day ago or 7 days ago. It really lets you constrain how your data grows, and it can let you focus on the current state of the system. All right, well, that was a very specific explanation of a very specific tool we use. You might be thinking, should I use this in production? Well, of course, the answer is that we do, and it's worked out well for us because I think it's just such a challenging problem space. And to use this yourself, you do really have to know what you're doing for now. So I'm happy to say the protocol has been open sourced for a bit, and it's here on our GitHub. It's not quite turnkey yet. I'm working on building out some of the documentation and the examples. And so this protocol is open source, but you'd still have to implement your own event log storage and processing pipeline. We have kind of our own solution on this, but this is something you have to roll your own. And the benefit is it does give a consistent, reasonable, and explainable abstraction of just how do I think about these two different systems with this unreliable connection, and how do I make sure that they're talking to each other in a reliable way. So if you're interested in this, talk to me. I'd love to hear from you, whether it's like I have had this exact challenge and this is how we fixed it, or like there's this protocol that you haven't heard of that does it a better way. I would love to hear that. Or if you're like, how do I solve this problem? How did you guys do it? I've talked to a few people already at the conference, and I'm very interested in hearing more from folks about that. And I think there's a real need and opportunity in this space. Everyone is like, we use this whatever protocol at work, and we hate it because of X, Y, and Z. And so I would love to see in 2022 people coming together and finding maybe a more modern way to deal with this. Given kind of that's where we are, where is this going? Well, so there is an example application on GitHub. It's probably the easiest way to get familiar with this is to try and start using it or to see an example. So that's one there. I'm going to work on put together a few more. In my talk last year, I talked about this idea of the batch publish. So this was really a way to save bandwidth. It's not quite done yet, partially because we found enough bandwidth saving just by moving to the solution anyways. But also there's one or two error cases which I haven't worked out the exact way the protocol would work on that, but I expect that to be coming. This connection request and response, it's like 95% done. I'd hope to have it done by this talk. Just busy enough at work. It didn't work out that way, but it's like at the finish line. And so the fun stuff kind of on my wish list are I'd love to have a batteries included event log implementation where you can just take this, you can do mix install, and you can just go. And that would be great. Some of the challenges here are this event log. In some ways, it's an append-only log where you just have the systems doing things and you're just writing the most recent stuff. And that kind of makes sense. But in some ways, it's also, you need sequential access where you're like, well, for this one particular meter, give me the last 10 readings, or just some kind of random access data like that. So depending on your use case, you can kind of have conflicting ways that you want to use the data structure. So that makes it a challenge. It also makes it fun. But that has kind of limited the whole, like, here's a simple way to do this. And then the really fun idea is I would love to build this sync broker, kind of like Kafka or something where your devices just connect and say, here's all my events. And then your cloud connects and says, like, give me all the events. And this broker handles everything, like authentication, scaling of data, geographic redundancy. I just think that would be just such a solution for people in this area. And it would be a ton of fun to build, but I don't see it happening anytime soon. So real quick, how does Elixir fit in? Well, like I said, being able to do this on the client and the server is just the best. It's helped us roll out features so much faster, so much more cohesively. I've heard of other teams where they are, like Elixir in one place and like C in another, and it's just like different teams and people don't get along because they see things differently. So this has helped us. Message passing has been a good model to fit in. And Broadway has been another great way to get these events going through the system. And I want to give a big shout out to the Nerves team and Nerves Hub, which has really helped us to easily update and remotely troubleshoot our devices. I don't know if we could do this without it. And a big lesson is that open sourcing things is hard. And I really have a lot of respect and appreciation for the Elixir and the Nerves team who put out just such a quality products and all the other open source contributors out there. So a big thank you to the audience for people who listened to this, people who showed up, community who puts out so much free good stuff, to my company SparkMeter who pays me to work on this and paid me to come to the conference, and the Nerves team, and lastly my coworker Benjamin Milda. You may know him as Lost Cobra Kai. He and I work on a lot of this stuff together. And lastly, I want to give a big shout out that we are hiring. We have an Elixir dev, which is posted. All these are posted on our website. Elixir dev, a full stack Python dev, and then product manager, product owner kind of thing. So that is everything, I believe.